We're here today. We're going to go through a bit of a journey from where we started from a corrective action in relation to excavation from an FSC audit through to a current scenario where we're trying to design out a lot of the risk through safety and design considerations. So just a quick brief who we are. Hindmarsh Construction, we're a family-owned and operated business. We've been around since 1979. We've delivered about over $6 billion worth of projects. We operate in the ACT, New South Wales, South Australia and Queensland. We've been accredited, as David said, for a long time, since 2006. We have delivered a lot of scheme projects. We do focus on technical and complex construction projects. I've been in the role that I'm currently in for about 5 years, been within the business though for about 13. Glenn has been our ACT State Manager for about 12 years. He's been around for about 16. He's very hands-on. He's been involved in this process from the start. Was at the audit where we got the initial corrective action. Has been heavily involved with the team in the scenario that we're going to present on. And then finally in the room we've got Andrew. He's been with us for 2 years. He's got over 30 years experience. He's going to take us through basically a scenario on site where the design solution required modular shoring. We've identified risks around this and he's leading the team currently in a safety and design approach to re-engineer a more appropriate solution for us and the client. Well, common issues in excavation found by the OFSC lack of regular document inspection, shoring systems designed by qualified engineers, installed by competent people, as Ralph touched on, and risks identified and relevant control of adjacent buildings and structures. So we're going to be touching on the shoring systems. That's where the corrective action came in, and very much so one of the driving factors of this safety and design process in a scenario we'll be talking through is around control of adjacent buildings and structures on this particular project. So the car that we started out with was from 7.5 and it was around training of workers for the installation of the shoring. We started this journey in 2017. So I'll hand over to Glenn, who's going to talk us about the journey that we went on, starting at downstream on controls, really controlling what our site contractors did, and then to the upstream controls that we're looking at now, where we're looking at safety and design.
Okay, thank you, Dane. It's been quite a journey for us since 2017. The process that we took was to, shore up our excavation permit. We had a look at our excavation permit and made some adjustments and changes to that to align more clearly with the FSC criteria. So what we looked at in the permit itself was, can an unmodified engineer certified modular shoring system, and the examples have been given such as the trench shield, shoring box and drag box, that extends the full depth of the trench to be used. And any changes to the modular shoring system, again, shall be authorised by a qualified geotechnical or structural engineer. If you're looking at making any changes, that's the process that we've built into our system. Moving through our permit, we look at manufacturer's instructions readily available, and have you conducted a consultation session? An example of that would be toolbox talks and pre-starts with the workers that will be installing the modular shoring system, and reflecting again the manufacturer's instructions or installation requirements. We've built that into our permit to fill that gap, and of course we have that as part of the attachments to our permit. But prior to that, we looked at our excavation workshop. Before you are able to fill out one of our excavation permits on site, we have a requirement that you attend one of our excavation workshops. So we've done a couple of different varieties of that. As you can see there, civil and piling workshop developed, which has some different hazards and risks to a detailed excavation workshop. So we've dialed those in to suit exactly what excavation is happening on site. And as I said, only workers that have attended that workshop will be available to complete a HCA excavation permit. Our excavation workshop, there's several codes of practice, so we really built that around excavation codes of practice, so there's nothing in our workshops that should be a surprise to anyone who wants to commence excavation on site. Some of the preferred controls that we look at in our workshop, and that's really is our main consultation and communication point the workshop. We look at confirmation that the modular shoring is designed by an engineer and specific instructions in that particular shoring system being used shall occur. We also look at confirmation that hydraulic shoring, sheet piling, timber shoring, trench lining and ground anchors shall be designed and verified and authorised by a qualified engineer. Again, we get that recurring theme. That's our journey through the permit and the excavation workshops. They're very effective on sites and we've got great feedback from those. So what I'll do now is I'm going to hand you over to Andrew, who's going to run through a current scenario that we have on one of our sites at the moment.
Thanks, Glenn. I'm working on a project currently where we have a situation where there's a complex kind of detailed excavation that needs to occur. We are working through the process as a project team with a view to trying making that installation safer and a better outcome for us as the construction team and also for the client as a whole. So just to give you a bit of an overview of the scope of this piece of work. There's a existing campus roadway. So on a site where there's a bit of a campus and they have some internal roadways, this project requires the excavation in one lane of a roadway, or they've designed a modular culvert system to create a tunnel in that roadway. It's about 45 metres long and up to 3.4 metres deep. As part of that installation, there's sections of the culvert. That area highlighted there in blue is the work we have to do. And there's a section there highlighted separately, which has been completed as an early works project separate to our piece of work. The primary aim of the tunnel is to install pipework, mechanical and hydraulic pipework around the campus from a central energy plant to other buildings on the campus. This is the design section through the proposed culvert or tunnel system, and you can see that's buried below the roadway, which is making the excavation quite deep. In terms of the constraints on the site and some of the sort of red flags that popped up for us as part of this installation, the current roadway has a sort of public footpath directly alongside the work zone. Whilst it's a road on a campus, it's a publicly accessible road, so there's actually a lot of pedestrian drop-off that happens at the bottom of that drawing there. As part of the scope of the works, the client has a preference to maintain some vehicle access in that roadway during the installation of that culvert, which obviously introduces some challenges. And so the vehicles would travel this way adjacent to our installation. There's an existing works that have been done on site prior to the installation of the culvert. And in part, there are electrical conduits that run parallel, but also cross the proposed culvert. And as you can see from that graphic, the conduits that are installed that we've surveyed would run right through a section of that precast culvert. So there's a number of challenges associated with the existing services. The design of the system, as documented, proposes the use of shoring systems in the excavation to allow us to install those culverts. And there are also challenges with those shoring systems based on the position of the existing footpath and those shoring systems being adjacent or right up against the existing curb or footpath. Our approach to this piece of work was really to look at the design and the site, and we conducted some survey of existing services and the likes, and we had a geotech engineer provide advice regarding the current design. The risks that are from the discussions previously and in line with Hindmarsh's management systems that Glenn described have been updated over recent years, we conducted a complete risk assessment of the installation. What we identified was these high risks that were there that needed to be dealt with as part of the installation. And just a sort of summary of those risks really is that the excavation at approximately 3.4 metres deep was obviously greater than 1.5, but also greater than 3 metres. The site contains a lot of weathered rock in the site environment. There's excavation of that rock in this works, and that introduces a potential for collapse as rock is hammered out and pulled out of that excavation. And obviously there's the issue around the adjacency to the public area and the protections that would have to be in place around that. Now, we've also got a situation where the design using precast concrete culverts, they weigh in excess of 7.5 tonne each, those sections of the culvert design. And so there's craneage that would be associated with those precast culvert elements. that crane would have to set up adjacent to our excavation. So just introducing a range of other risks that would need to be dealt with. In us addressing that or conducting that risk assessment, what that flagged for us was the opportunity to consider alternative designs for the installation. So it was really about going back to that first level hierarchy and designing out a number of the risks. So for this installation, and from the information we gathered during the survey of the site, the services survey and the geotech inspection, the alternatives that we considered that were reasonable were using the current culvert design and bringing it to the surface just to reduce the overall depth of excavation. Considering a board, pier and shotcrete solution, which would enable us to do a lot of that shoring as part of the installation, and then also introduce a lid on top of that shotcrete system, or direct burying the pipes or the services into the road. So again, we had a much smaller excavation that wouldn't need such depth and therefore could manage the controls and minimise the need for shoring. Whilst we considered these options, they each had their own constraints and risks, which we sort of needed to assess. And part of that process was really around engaging with the client to just understand exactly how their design was developed, and also to really work through with them their constraints, highlight the risks that we identified and discuss the alternative solutions. The way we did that, we had a number of sort of informal meetings with the clients just to get some discussion around those risks, what the effect they would have on our construction and the effect they would have on the campus of that client. Working with our special subcontractors and our geotech engineer, we put together some preliminary sort of sketches and images and the likes to demonstrate what the alternative methods might be. And we worked through those with the client, presenting them in a sort of fairly informal way, using a sort of PowerPoint presentation, even just like this one, just to highlight what they are. Part of that consultation with the client was really identifying what was critical to them in the design, what was a sort of need to have item and what was a nice to have item in the design of their system. And considerations were things like having access to the road that they were keen to have, the road still operating, or why there needed to be a culvert and we couldn't do a direct burying solution. So we really had to tease out what the real issues and real requirements were for the client. So then we could help simplify the sort of alternative solutions. I guess running through those scenarios, just as an example here, this is just a little section sketch that we use to present the issues to the client. And obviously the primary option, we know that we've got these shoring that needed to occur. We've got a relatively deep excavation and some craneage that needs to occur in that scenario. One of our alternative scenarios was to bring that culvert section closer to the surface, which reduced our depth. As you can see from the conduits that are shown running through that tunnel system, that introduces its own constraints. And it didn't really minimise our risks significantly. We still had the craneage required for the culvert. We still did have to excavate, and given the size of the culvert, we still needed shoring system anyway. One of the other alternatives was a board piers and shotcrete sort of scenario. This system obviously requires some additional engineering. We have to engineer the piers and the shotcrete shoring system, so that needs to be considered. What it does do is provide stabilisation during the excavation, so not just the finished product, but during the excavation before you get the full depth. There's some opportunity to introduce stabilisation with that shotcrete and the board piers. Another thing it does is significantly reduces the craneage. Because we don't have these large precast culvert sections, we then minimise the craneage that's required there. Now, there's obviously other issues that are being introduced, like concrete that we need to get in there for the shotcrete and for installing a concrete lid. There are some risks that are minimised and some that change. And the third option was a direct buried trench. And the benefit of a direct buried trench, I suppose, is the heights can vary. In this section, we've shown where the pipework could go below existing conduits. But it also means that that pipework could be brought closer to the surface, so we didn't have to have a deep excavation for the entire sort of 45-metre route. We thought this a viable option as an installation methodology. But then in consultation with the client, they're saying it didn't really meet all of their criteria. They were targeting having that tunnel so that it was re-accessible, and then they could install additional services later if they needed to without further impacts on the road. So there's some of the considerations we gave to working through alternative options, considering what those alternative options would be, and consulting with our client just so they could better understand what we'd identified, but also for us to better understand what their constraints and issues were. I guess the next step in the process for us in terms of trying to design out the risks that we'd identified was really about completing a more detailed assessment. Once we'd had the preliminary consultation with the client and we're able to reduce the number of alternative considerations, we essentially were working with two options, which was the original design and the board, pier and shotcrete solution that they considered a viable alternatives that still met the scope needs for the client, but it also assisted us to help reduce the risk for the project and for the construction. So then for us, it's about completing a sort of fairly detailed risk assessment of those two systems. So we started to do, or we'd done a risk assessment early on the project about the culvert section, and we had to do the same risk assessment for the alternative solution that's being proposed. I guess the key issues there are about comparing the results of risk versus functionality for each option, and then identifying the most effective options that you can further communicate with the client and look to develop out as a design. So the steps we take then to really work through how we might re-engineer this solution is to submit a sort of detailed proposal to the client. And this includes providing a detailed description of the problem and highlighting the risks that we'd identified and the alternatives. And given that we've been along the journey with the client on this, we were able to minimise the amount of effort by minimising the alternative options. Then we looked to use a safety and design methodology. And Hindmarsh have some fairly robust safety and design tools available for us. So we use those to work through all of the risks, both construction risks and the post-construction operational risks that would be typical as a safety and design approach. Again, working with the client and other stakeholders at the site, we're able to clarify the critical requirements, like then try and keep their tunnel for future upgrades or changes. And that enabled us to sort of identify the safer solutions and the safer options. One of the key things was working through this with the client. They were willing to forego the continued use of the roadway and sort of negotiate that down to, we have a couple of key dates where we need to have the road open and we need to build your program which works around that. So that allowed us to better work in the confines of the site and then be in a position to give the client the space they needed, but also take all the space that we needed for a safe installation. A final proposal to develop this through to a change would be provide a detailed description of what needs to happen, complete a risk assessment for each installation, develop a program or a timeline for the installation. And that often helps with the client consultation, because if an alternative system that uses different safety mitigations might actually speed up the construction time. It's about getting engineers' advice and developing the design through using appropriate engineers just to get a final solution that would able to meet the client's needs and also meet our needs for a safe and effective installation. In summary of the approach we took for this project, it was about thoroughly assessing the risks of the project. It was about, instead of introducing more controls downstream on the worker group that have loads of controls already, we took a safety and design approach to propose a safer option upstream to the client. Working with the client, we identified the real requirements for them. So obviously the key issue was to get the pipework down the roadway. But for them, they wanted the tunnel arrangement so they could do future changes and upgrades, or have the opportunity to do future changes and upgrades without further impacting on this road, because obviously the issues surrounding this access way on their campus was quite critical to them. And the other thing was about using trained and skilled and experienced people to develop the solution, but also to implement the required controls. And this is part of the discussion that was had earlier around ensuring there was competent people installing shoring systems. And this is no different in terms of developing a safer approach. We've relied on engineers and our specialist subcontractors, our civil contractors and our services contractors to ensure that we could develop a solution. As it happens for this particular project, we're right at this phase of the final proposal. So we don't actually have an outcome yet. But what we've done is to develop an alternative solution that designs out the risks or some of the risks and still provides the functionality required for the client. So that's our sort of scenario, our case study in summary. That's where we are going with the management of those risks.
Thanks, Glenn and Andrew. So yeah, look, if anyone would like further information, feel free to contact me on that email address, and I can get information off Andrew or Glenn as required. So thanks for your time, and I'll hand back to David.